So hello guys, welcome back to our channel. In this video, we will solve a problem from chapter 3, which is the ideal gas. So here we have a problem. The amount of pressure in the car tire depends on the air in the tire's temperature. The pressure gauge registers 210 kilopascal at a temperature of 30 degrees Celsius. Determine the pressure rise in the tire if the volume of the tire is 0.030 cubic meter and when the air temperature in the tire rises to 55 degrees Celsius. Also, determine the amount of oil that must be bled off to restore pressure to its original value at this temperature. Assume that the atmospheric pressure is 100 kilopascal. So this is our figure, and we have the given values. This problem, the volume equal to 0.03 cubic meter and our temperature is equal to 330 degrees Celsius. We have to convert this into Kelvin. So we have 30 degrees Celsius plus 273 Kelvin, or 273 rather, is equal to 328 Kelvin. And our gauge pressure is equal to 220 kilopascal, and our temperature at state 2 is equal to 55 degrees Celsius. We have to convert this into Kelvin, so we add it again 273, and we have 303 Kelvin. And our atmospheric pressure is equal to 100 kilopascal. So in this problem, we are going to find or determine the pressure rise in the tire and determine the amount of oil that must be bled off to restore the pressure to its original value. So here we have a property which is the gas constant of air equal to 0.287 kilopascal per cubic meter per kilogram per Kelvin, and that can be seen in our property table at table A-1. So in this problem, we assume that the air behaves as an ideal gas and the volume of the tire remains constant. So again, this is our tire and at 30 degrees Celsius. So first, we have to solve for the absolute pressure. And the formula for the absolute pressure is equal to gauge pressure plus atmospheric pressure. So plugging in the values, we have 220 kilopascal plus 100 kilopascal. We get 320 kilopascal. So that is our absolute pressure. Next, we need to solve for the final pressure denoted by P at state 2. So we have the formula U1 V1 over T1 is equal to P2 V2 over T2. Since we don't have V1, so we will cancel that. And cross multiplying this equation, we have the final pressure P2 is equal to T2 rather, divided by T1 multiplied by P1, or the absolute pressure. So plugging in the values we already have, we get 328 Kelvin divided by 303 Kelvin multiplied by 320 kilopascal. We have the final pressure equal to 346 kilopascal. Since we already solved for the absolute pressure and the final pressure, now we can solve for the pressure rise. And the formula for pressure rise is equal to final pressure minus the absolute pressure, or denoted by P at state 2 minus P at state 1. So plugging in the values, we have 346 kilopascal minus 320 kilopascal. We get 26 kilopascal. So this is our pressure rise, 26 kilopascal rather. Next, we need to solve for the amount of air needed to restore pressure to its original value. So first, we need to solve for the mass at state 1. So we have the formula P1V1 over RT1 is equal to, plugging in the values, we have 320 kilopascal multiplied by 0.03 cubic meter all over by 0.287 kilopascal per cubic meter per kilogram per Kelvin multiplied by 303 Kelvin. So kilopascal will be cancelled. Also, cubic meter will be cancelled. And Kelvin also will be cancelled. So our remaining unit is kilogram. So we have the mass 0.1104 kilogram. Next, we need to solve for the mass at state 2. So we have the same formula and plugging in the values. So we have 320 kilopascal multiplied by 0.030 cubic meter all over by 0.287 kilopascal per cubic meter per kilogram per Kelvin multiplied by 328 Kelvin, since we are not at state 2. So again, we have to cancel kilopascal, cubic meter, and Kelvin. So we have the remaining unit, which is kilogram. So we have 0.1020 kilogram. Since we already have the mass at state 1 and state 2, now we can solve for the amount of air needed to restore pressure to its original value. So we have the formula, the delta M equals 2M at state 1 minus M at state 2. So plugging in the values, we have 0.1104 kilogram minus 0.1020 kilogram. So our final answer for the amount of air needed to restore pressure to its original value is 0.0084 kilogram. So this is our final answer. the pressure rise is 26 kilopascal, and the mass or the amount of air needed to restore pressure is equal to 0.0084 kilogram. So I hope you understand this problem, and thanks for watching.